Hello everyone, today in this video we'll be discussing the third module of 21CIV14, and in this module we have mainly two topics, which is centroid and inertia. Okay, so we'll have some numericals and the formulas and the derivations in both of these, which we'll be discussing now. So before starting, if you like this video, hit the like button and don't forget to subscribe to my channel. So let's get started with the first one, which is centroid. Okay, what is centroid? Before getting to know what is centroid, you need to know what is center of gravity and center of mass. Center of gravity is the point at which the total weight of the body is assumed to be concentrated. So if this is the means the whole object, if there is a center of gravity, that means the whole point means the weight is concentrated on this particular position. So if you hold from your finger like this, then it will be balanced. Okay, so that's what the center of gravity is. Center of mass also the same thing. It's the center of, means the whole mass of the body is concentrated in the particular position. Okay, and the centroid is the point at which the whole plane is assumed to be concentrated. This is the centroid. Then two things you need to know: what is the x value of centroid and y value of centroid. X value of centroid is taken from the y-axis, because x distance we need to know, we can only take from the y-axis, and y centroid we can just take from the x-axis, because this is the y distance which is to be covered. So this point where it lies from the y-axis is known as x centroid, and from the x-axis where it lies is known as y centroid. So these two has the formulas for different kinds of objects, which we'll be using to find the centroid for. Okay, so another thing which we need to know is how to determine centroid by moment is, like if you want to determine the x centroid, we will be dividing the means the object in different areas. Like here it is a1, a2, a3 and a4, and then what is the distance till a1 it is x1, till a2 it is x2, till a3 it is x3, till a4 it is x4. Then we will be multiplying them, like a1 x1 plus a2 x2 plus a3 x3 plus a4 x4 divided by x1 plus x2 plus x3 plus x4. Okay, sorry, a1 plus a2 plus a3 plus a4. Okay, this multiplication in the top and the division in the bottom. Okay, so like that, if we divide, we will get the value of x. Same thing we can do for y as well, like ay, a1 y1 a2 y2 till a and yn divided by the whole sum of the areas. Okay, so in that we can find both the values of x centroid and the y centroid. Okay, so yeah, that's all, and we'll be solving some means the official figures, like the rectangle, triangle, circle, semicircle. Those figures will be finding out what is the centroid formula. Okay, so if they ask you in the exam for the derivation, you have to do it as follows. So the basic concept in all of these derivations is that you will be considering a small element. Okay, this is the small element, and if you find out the centroid for the small element, we'll be finding out for the whole element by integrating it from 0 to what is the length of it. For example, here as you can see, the elemental area dA, this is the area dA, it is given by dy into b, because that's what length into breadth, right? That's the area dA. And after we have got the area, like I discussed earlier also, a into y, that summation divided by area summation. Okay, so area a into y is dA into y. dA is this one and y is this one. So the integration for it will be the whole summation, right? For the whole summation divided by a. A is nothing but the total area, which is nothing but b into d, that whole area. Fine. Like that we will get the value of y bar. Now we will be cross multiplying it to find out the value of the integral. So what is dA? dA already we calculated is b into dy. So just substitute that and find out the integration. The integration limits are from 0 to d, because this element, if we find out, then we have to find out for this whole element. It's running from d is equal to 0 till d is equal to d. Okay, so we'll be doing that, and yeah, that's all. We'll be finding out the value of y dash, as well as similarly the x dash value will be also d by 2. Okay, actually x dash value will actually be b by 2, because this is x, right? So it will be b by 2 here. So anyways, that's the concept behind the centroid of rectangle. Coming to the triangle part, we have two types. One is right angle triangle, other one is isosceles triangle. So for the right angle triangle, let's see how to do. Same thing, consider a small element here, and in the element what we have is this, the dy. Okay, this is the dy, this length, and this is b1 length, and this is total is b, and the total here is h. Okay, so if we apply the similarity of the figures, what we get is b1 by h minus y is equal to b by h, because what is h minus y? H minus y is this one. So what two triangles we are considering is this triangle and this triangle. So this length by this whole length is equal to this length by this whole length, isn't it? So that's what we are writing here. H means h by h minus y is equal to b by h. Okay, actually it is b1. Okay, this value b1. So b1 will be equal to b into h minus y by h. Now we'll be using this value of b1 in the equation dA. Okay, because the elemental area of this one is, this is like a small rectangle, right? So it will be b1 into dy, right? So this is the area for b1 into dy, then we'll be finding out the area for the whole means triangle. So for this, if we get b1 into dy, what is value of b1? It is nothing but we've just calculated b into h minus y by h1 means h. So we substitute that here, and then we find out what is the value of dA, then we integrate it, and substitute the value of integrate from the limits 0 to h, why 0 to h, because that's the limit of the whole rectangle. Like we are considering this element runs from h is equal to 0 till h is equal to h, right? So that's what we are doing here. We are just putting out the limits and calculating the answer. In the same way we get for the x also and for y also. If we do like we had done this for y, if we do for like x dA by dA, at that time we'll get the value of x integral also. That value is nothing but b by 3 and y value is h by 3. You can remember it easily as follows, like this is h by 3 and this is base, right? So it is b by 3 here. For x it will be this one and y it will be this one. Just tilt this figure in this way, then you will get the height as x, this same value as height, right? So it will obviously be b by 3 because this is base here and the height is here, it became h by 3, b will become b by 3, right? That's what it's given here for the right angle triangle. Moving on, the same way we have the isosceles triangle and equilateral triangle. Here just the derivation part is same. You can do the same things what we have done here, like the similarity of the figures. Here also two figures which are similar, which you need to consider is this triangle and this triangle. So this base by this length is equal to the height, this height by this height, right? The total height. So in the same way when you do, you'll get the answers as y dash as h by 3 and x dash as b by 2. Okay, moving on, we have the semicircle, and in semicircle two things you need to know, because two times we are integrating. Why we are integrating two times is because if you consider the overall structure of semicircle, this is the theta value, okay, and this is the part of the semicircle, and in this part you are not considering the whole part at once, we are considering a small element of that part. Then when we find out this element, we will be finding out the whole part of this one. Okay, this is from 0 to r, this 0 and this is r, the whole radius it is found. After we find out for the whole radius, we just need not have this much part only, right? We need for the whole semicircle. So we'll be again integrating it from angle is equal to 0 till angle is equal to 180. So two times you are doing integration, fine. So it is symmetric about the y-axis, so x bar will be 0 because this is symmetric, right? So it will be 0, but y bar will not be 0 because here we have to find out one point which is acting as the centroid. Okay, so sin theta is equal to y by r. This you have to practice by writing. I'll just explain what's happening here. First they are taking sin theta, that is equal to y by r. Okay, so sin theta, if you consider it like this, at that time this is the value of r, this is the value of y, so it is y by r. Okay, sin theta is y by r, so y is equal to r sin theta, and elemental area dA is equal to r d theta into dr. What is r d theta into dr? R d theta is this value, right? This length is r d theta, this is d theta, this is r, so this length is r d theta. R d theta into r, this will give us the whole not r d theta into r, but r d theta into dr. This is dr, a small part of r, and this is r d theta. So we'll get this area. After we have got this area, we have to just expand it to the whole area. Means you have to integrate it from 0 to r, right? That's what we are doing here. We are integrating it from 0 to r. After we are integrating from 0 to r, we will get the whole area of this part of the semicircle. But we need to calculate the part of the whole semicircle, right? Not just this part. So we'll be again integrating from the theta value 0 till theta value 180, which is nothing but pi. So we are integrating from 0 to pi, and we do the double integration by applying the values of r d theta and all. So I'll get the following. This is just the simplification part, and we'll get this value of y is equal to 4r by 3 pi and x bar is equal to 0. Okay, same thing goes for semicircle as well. You can go through it. We are just changing the limit of 0 to pi by 2, because in quarter of the circle it's from 0 to pi by 2 only, right? Not pi. That's the only difference which is happening here. So the answer to get is 4r by 3 pi in this case, and x is also 4r by 3 pi. Why? Because it's not symmetric with respect to x-axis, right? Here if we consider the x-axis, here nothing is there, here something is there. As well as when you consider the y-axis, here something is there, here something is not there. So it is not symmetric with both respect to y and x-axis. So we can consider that, right? So yeah, that's all what we are doing here. And sector is also same, just the limits are from minus alpha to alpha. You observe carefully what's happening here is we are integrating first from 0 to r, then from this minus alpha till alpha. That's the only difference which is happening in both of these cases. Then the cos theta and all, you can easily find out what is the things. R and 0 is same here, and minus alpha to alpha is here, and yeah, that's all. Okay, that's the area of sector. And this is the x value and the y value which we get in the answer. Okay, so that's all about the main important figures which you need to know, the centroid thing. And these are the shapes and the figures. This is the important formula sheet, like that you can consider. For the rectangle, this is the area, this is the x bar value and the y bar value formula. Same thing goes for triangle also, right angle triangle, circle, semicircle, quadrilateral circle, and sector. Okay, so you can go through it if you want to solve the numericals and all. This is like a quick reference sheet. Okay, that was about the centroids. And let's see one numerical, how to approach this problem. Means in the centroid, if they ask you the numericals, how are you supposed to approach. Okay, so this is the kind of the figure which you can expect in exam. So here there are two figures. If you get this figure, first thing which you have to do is draw a symmetric line. Here if you draw one line like this part is symmetry and this part is symmetry. That's the first thing which you need to do. Okay, after you have done that, divide the shape into how many parts you can. Like here I can divide into two rectangles, right? Like that you have to divide into the number of parts which is possible. Okay, after you have divided into two rectangles, then we will be finding out the centroid for each of these. Then we will be calculating the centroid for the whole figure. Okay, let's see how it's actually happening. So here as you can see, the division has happened. This is the symmetric axis. Okay, and this is the lengths and the measurements which are given in the question only, and these are the two rectangles. This is one rectangle, this is another rectangle. Okay, after that, let's consider each rectangle one by one. And what all you need to find, we need to find out the area and the y value and area multiplied by y. These three things you have to find out. What is the y value? What does y value mean? Y value means for the first rectangle, the y value is this one. What is the centroid point of the y value? Since you have divided it with respect to y axis, you will be finding out the centroid for y. You have divided it with respect to y axis, you will be finding out the centroid of y. Okay, so y bar's value is nothing but b by 2, right? B by 2 or h by 2, whatever you consider it. Okay, so here the centroid value will lie in between here. So that if the total is 120 meter here, the mid part of it will be 120 by 2. That's what we have derived in the earlier cases also. So if you see the rectangle here, the value of y is nothing but d by 2. What is d? D is this length divided by 2. There you will get the centroid for y. So to find out the centroid of y, divide the length of that rectangle by 2. So it is 120 by 2. That's what we have written here, 120 by 2. Cool. So here it's area, here it's y, and then just multiply these two to get this answer ay. Same thing you do for this one also, and you will get one answer here, ay. Now remember, like we had find out ay values. What is the value of y bar? Y bar is nothing but ay divided by summation of areas. Summation of areas we can easily get. We have find out the areas here, just add it up, and summation of ay also easily we can get. After you get these both values, just divide them to get the value of y bar. Okay, so this is how you find out y bar. Same thing you do for x bar as well. Reference is y axis. Okay, so this is how you are supposed to answer the question. And here also the same procedure. I'm not going through it in very deep manner. Just briefly I'll tell you what to do. Divide this into three rectangles. After you have divided into three rectangles, find out each means the value of x bar and the y bar also. Here it's not symmetric, right? Because you can't divide this into two equal parts. This is not symmetry, this is not symmetry. If you divide like this also, it is not symmetry. So you have to find out both x and y also. When you find out both x and y by applying the appropriate formulas for this, for the just rectangle, so apply the formula appropriate for rectangles centroid, and after that just multiply the a into that values of x and y. After that find out ax ay and directly find out what is the value of x bar and y bar by ay by a and ax by a. Okay, you can get two answers. These are the centroid values. And here also, here we have the semicircle, so we are dividing into three parts. Then do the same thing, x and y, apply the formulas. After applying the formulas, find out what is the answers. So let's just consider once here, like since a semicircle is here, let me discuss let me tell you what's actually happening here. What is the radius of it? See, this semicircle is there, right? This radius is nothing but this value. It is given as 2.25. Now let's see the formulas for semicircle. In semicircle, the formula of if you are considering the symmetry in this way, it is y bar, right? What is y bar? Y bar is nothing but 4r by 3 pi. So if we consider 4r by 3 pi, we just have to substitute the value of r in that case and just find out the answer. Okay. So if you observe carefully, this is nothing but 4r by 3 pi, 4 into 2.25, which is r, by 3 into pi. This value you have got, but the question is why you have taken minus here. You have taken minus here because the figure is as follows: this is the y-axis, this is the x-axis, and anything to the left of y-axis is taken as negative. So the radius will be negative here, right? Same thing goes for in this case also. If this is the y-axis, x-axis, and the figure is given as follows, here also the value of means whatever the radius comes below this one, that is also taken as negative, right? So that's why we have taken that negative value and just substitute there as negative and find out the answers as usual. A value summation and ay and ax value summation, and divide them by the appropriate terms, and we will get the value of x and y. Okay. And here one difference is that this is also the same thing, everything you will be doing in the same way, but observe carefully where is y, this is y and this is x. But here it's semicircle is getting subtracted, so here also you have to take negative value, okay, because subtraction is happening here. Here also subtraction is happening, so 2 times negative value you will take, rest of the things are same here. Just consider each of these component, find out the x and y values, ax, ay values. Wherever it is semicircle, take it as negative, and the quarter circle is also taken as negative, just because it is getting subtracted here. Okay, that's why we are taking negative. After that, find out the value of summation of a, summation of ax, summation of ay. Find out the value of x bar and y bar by summation ax by a and summation ay by a. Okay, so that's the final answer. So this is how you approach the centroid problems, and the similar thing is in the the next one, moment of inertia, also the same thing is there, just the formulas are slightly different and the derivations are slightly different. So let's see what it is. So what is moment of inertia? The secondary moment of area of the lamina about an axis is called moment of inertia. So let's understand by this example here. In this example here you have the area A1, A2, A3. So x values and the y values are given to us. So if you want to find out the value of the moment of inertia about the x-axis, moment of inertia about the y-axis, they are different formulas. So for the y-axis, if you want to find out, it will be a1 x1 square, a2 x2 square, a3 x3 square till a n xn square. Okay, so it will be ax square, the summation of ax square for y-axis, and for the x-axis it is summation of ay square. Why? Because if you want to calculate the value of this one, what is the distance till here, what are the distances till here, those distances are nothing but in the x terms. So for the y axis you are taking the terms in the x direction, and for the y terms you are taking the means this is the x axis, you are taking the distance in the terms of y. So for x it will be y, and for the y it will be x, just remember that one. Okay. And here are some important theorems. The first one is the perpendicular axis theorem. In this, the any z value, means if you consider 3D plane here, the moment of inertia about the z axis is nothing but the moment of inertia about the x axis plus the moment of inertia about the y axis. These two summation of the moment of area gives us the moment of inertia of the z axis. Okay, so the proof is as follows here. So if you consider a small area dA, and this is the value from the from the y-axis, and this is the value from the x-axis. So what is the moment of inertia? As I told you, this is the area and the distance in area into distance square. This is the area, distance square, area, distance square. So dA into y square, dA into x square for ix and iyy, and for the izz it will be nothing but dA into r square, because the distance from this one till here it is r, right? So it will be r square. Now if you add it up like ixx plus iyy, if you add it up, what you will get is x square plus y square into dA. This is nothing but r square, so r square into dA is nothing but izz, right? So that's what we are writing here, d into r square is izz. This is the proof for the perpendicular axis theorem. Next is the parallel axis theorem. So let me just explain you what the parallel axis theorem says. So if there is a circle here and there is a small element here dA, and the whole area is A. Now if you want to calculate the moment of inertia of AB, at that time you will find out what is the moment of inertia of this point. Okay, ixx. So if you want to calculate the moment of inertia of this polar axis, which is AB, at that time it will be equal to this one, ixx plus what is the distance between them into the area. What I mean is this one, I of any axis is equal to ig. Ig is nothing but this one, xx, and plus ah square. A is nothing but the area, h is nothing but the distance between this one and this one. So what we are calculating? We are calculating the moment of inertia about this axis. So find out a parallel axis. If you know this moment, then it's nothing but very easy. this moment plus the area into h square. That will give us the moment about this axis. For that we are just taking the stripe of means strip about the x axis, means this strip here, the area will be nothing but dA. In this case the area is dA and it is y square, the distance is y here, so it is y square. After you have got the moment of inertia of the strip about the x axis, from here it is y distance, so it is y square into the area is dA. After you have got that, the moment of inertia of the whole lamina will be equal to the summation of dA y square, which is nothing but the integration, right? So the same thing goes for here also. Ix is considered as Ig, so because it is the centroid value here, Ig and Ix are same things, so Ixx value we got here. The first part of the question is done. Similarly, the moment of inertia of the strip about the axis AB is equal to area of the strip plus the into the distance square. Area of the strip is dA only as usual. If you are just considering this axis instead of this axis, at that time what will be the distance till here? It will be h plus y. Okay, h plus y, this is the distance and the square into the dA into h plus y square. That's what we have written here, dA into h plus y square for the axis AB. And just integrating it, and means not integrating, the summation of it and expanding these terms here. After the simplification purpose, means after the simplification things, what we get is the total simplified answer is here. Okay, substituting the value of h square dA, dA y square and 2h dA in the equation 2, we get ah square plus ixx plus 0. 0 why? Because this is the negligible value. Okay, so if you go through it, you will get to know what I am actually telling. So see here, if you just go through it, what's happening, how many terms you get, 1 2 3 3 terms we got, and IAB, there is nothing but IAB, same thing, it is h square dA, dA y square and 2h and to summation dA y. And h square dA, what is the summation of dA? It's nothing but a, so h square a, that is ah square, and dA y square, what is dA y square? It is Ig into it is Ixx from the equation 1. dA y square for what value we got? We got for this one, right? This is dA y square Ixx, so we can directly substitute instead of this place, instead of this we can write Ixx. So that's what it's happening. This is the negligible value, so it is 0, this is Ixx and this is ah square. So here only we got the answer, Ixx plus ah square is equal to I of AB, right? That's what I have to prove in the given parallel axis theorem. So moving on, as previously we did, firstly we got to know what is the means, what does moment means, what does centroid mean. Here we found out what is moment of inertia mean, then we will find out the geometrical figures derivations, and then we will solve one numerical. Okay, so that's all what is there in the module. If you are thorough with these three topics, means these topics which I have discussed, like the derivation part and numerical part, then you can expect good marks in the module 3. Okay, so let's see the first one, which is the rectangular section. Here also the same thing, consider a small section here, find out the moment of inertia for the small section with respect to the base, because we are finding out xx. Okay, after we have found out that, we will be using either the perpendicular axis theorem or the parallel axis theorem to find out the moment. Okay, so here the area of the strip into the distance square, the area of strip is b into dy, this is b, this is dy, so it is b dy, and distance is y, so it is y square. This is the moment of inertia about the base. Okay, after we found out the moment of inertia about the base, we need to find out for the whole figure, so that's why we are doing the integration part here, and we get the moment of inertia about the base is b dq by 3. The same thing goes for the any other axis on the plane. So once we have got the base moment of inertia, we can find out the centroid moment of inertia, right? For the centroid moment of inertia, we'll be considering this part here, and the distance is d by 2, and by the same formula, which is parallel axis theorem, ig we just got here b dq by 3, right? This is the ig value, and ah square area, we can easily find out what is the h value, that's the distance, which is d by 2, and d by 2 square if you do, we'll get the area about the x axis. Same thing we'll do for the y also, and we'll get one area, means we'll get one formula that is for the y axis. Okay, so that's all what we have to do in the rectangle part, and finally we will get the answer here after substitution part, ixx and iyy values. You derive for one, and the next one you just write the formula. Okay, same thing goes for the rectangle triangular lamina also. Just consider the similar rectangles triangles here. After you consider the similar triangles, find out the moment of inertia about the base. First find out the base always. Okay, first find out the base, then find out the centroid. Okay, After, if you find out the base, like area of the strip is this one, you can easily go through it and understand what's happening here. The same thing we have discussed in the previous derivations as well. Find out for the whole triangle the lamina, and after we get that for the base, if we get, we can easily find out for the x-axis. X-axis is nothing but ig plus ah square, ig we just got here, and ah square you can calculate and substitute. Okay, so we get the moment of inertia for this one. So basically in all the questions we are considering a small area here, and we are finding out what is the moment of inertia for this line, and after that you will be using the formula this line moment of inertia plus a into h square. H is nothing but the distance between this one and this one's square. So that's the parallel axis theorem's application, and in that we can find out the value of ixx as well as iyy. Okay, so here also you have to do the same thing. Consider a small element here. If you just break this element and open it, it will look like this, right? So the area is nothing but the circumference into d, means what is the thickness of it, dr into circumference. This is the area of it, and we'll find out for the whole circle. After you find for the whole circle the area, the h value is taken as r, h square, the distance square is r square, small r square. So you'll get this one. This is the area and this is the r square. So this is the moment of inertia for the polar axis. Now we will be using the perpendicular axis theorem, which is nothing but ixx plus iyy is equal to iz. Ixx and iyy are same, so it will be 2 into ixx. Ixx value you just found out here for the whole circle. When you do the integration, you'll get the answer as pi r square by 8. When you do it into 2, it will be pi r square by 4. So that's the area of ixx and iyy. Okay. The same thing you'll be doing for the semicircle as well, but here you'll be using the perpendicular axis theorem. So parallel axis theorem here you will be using. So ig is nothing but the moment of inertia for the x axis. First you'll find out, then ah square you'll just multiply. Okay, so for the moment of inertia about the centroidal x-axis, this already we know it is pi r square by 4. We have found out in the previous derivation, and for the semicircle just divide by 2, it will be pi r power 4 by 8. Okay, so it will be pi r power 4 by 8 for any axis, and means I mean for the x-axis. For the any axis you will be finding out like substituting the values here. Okay, so this what you got for the previous one, like pi r power 4 by 8, ixx is as the previous one, and ah square is here. Ah square, what is a value you will get easily, means pi r square by 2, that is the value of semicircle area, and h is nothing but the distance between the x-axis and which axis we are trying to find out. So this is the axis which we are trying to find out, and this is the axis which you already know. So the distance between them we know from the centroid derivations, it is 4r by 3 pi. Just substitute that in the value of h, do h square, and just simplify to get the final answer here. Ixx value, same way iyy value is also pi r power 4 by 8. Okay, same thing you have to do for the quarter circle also. Parallel axis theorem, find out the distances ah square, which axis you are considering and from where you are considering, that you'll be substituting the values, and one of the values we already know, like moment of inertia about the same axis, diametrical x-axis, this value we already know, which is pi r power 4 by 16. Just divide by 2 for the previous one, you'll get the answer, and we'll be finding out for this one. Just keep it as such here, and shift the rest of the terms in the other side, you'll get the answer for ixx. Same way you'll do for the iyy also, but in this quarter circle it is same, so here you'll get the same answer. All you have to do is just practice, like writing it many times, then you'll get in mind what's the actual derivation. Okay, so if you know the derivation part, remember the formulas, and you can if you are able to solve the numericals, that's more than sufficient. Okay, so this is just the revision sheet. You can go through it. All the formulas are written here, and there is one numerical how to solve this type of questions for under the topic moment of inertia. So here the moment of inertia for the x-axis and y axis we have to find out. So to find out the moment of inertia, first you need to find out the centroid values, like in the previous numerical we did for centroid, right? That you have to do first and find out the value of x and y. Okay, so if you means you don't know how to find out that, first watch that part. Okay, and then get to know how to find out the x and y values, then proceed further. After you have got the x bar and y bar values for the given figure, after that you'll be doing these things. Okay, write x, y, ax square, ay square. Just substitute those values, x, y values, and means square it and multiply it with the a values, area values. So when you do that, you'll get these answers, and by using the formulas for ig values which we have just derived, by using those values for each of these sections, like for each of these cases it will be same like it is a rectangle, right? So for rectangle, what is the ig value? For if you're considering for the base, it will be bd cube by 3. If you're considering for the depth, it is db cube by 3. And if it is for the x-axis, it will be bd cube by 12. If it's for the y-axis, it will be db cube by 12. Consider the figure which you are considering, where you are considering the symmetry. From there, what is the value of this means the moment of inertia, that you will consider, and then you will be calculating the values of ig. Okay, igx and igy. After you have done this one, you have to calculate the value of I11. I11 is nothing but this one. What value you got for igx plus summation of a y bar square. Okay, y bar square, y bar we have already calculated earlier also. This is the value of y bar. Just multiply it with a and then square it and add all the values. So you'll get these answers here. This is the value of I11. I11 value we will be using in the ixx and iyy values. Okay, so ixx values, I11 minus ay square. Just substitute the values and find out this answer. And for the zz here, for the zz it will be igy plus ax square. So this is actually ax bar square. Okay, not ax square, x bar square, because here also we have taken y bar, right? So it is igx with y, x with y is there, and here y with x is there. Okay, like that we'll find out the value of zz, and finally when we find out the value of zz, we can use that value to find out the value of yy here. The first one, which is 11 is used to find for the xx, and for the means it is actually not zz, this is 2. Okay, so for this one we are using to find out the value of iyy. Substitute the value of what answer you get here, subtracted with a into x bar square, that answer which you get here, and that's your final answer. Okay, so two things you need to find out, what is xx value as well as for what is yy value. Okay, so this is basically what is in the module 3 of 21CIV14, and thank you so much for watching. I'll see you in the next one.